Welcome friends to Power Plant Guru YouTube channel. Friends, I am a mechanical engineer with around 20 years of experience in the field of power plant, and I used to create small fundamental knowledge series videos for power plant engineers. We also run doubt clearing sessions on weekends. So if you want to reach us, you can reach us through comment section and join our weekend classes. Let us continue to watch our today's video. Welcome to new video of Power Plant Guru. We are taking a series of videos on boilers, HRSG and steam generations. So we have come up with a topic of boiler circulation ratio. So in this topic, there were some questions and doubts which our viewers has asked. So we will try to clarify those questions and clear the concept. So these are some topics which are going to be covered in this video, that what is the circulation ratio and what is the importance? Is it linked with natural circulation and the forced circulation, or even once through boilers? And how does this impact us while the boiler is in operation? So let us cover these points and understand. And you can ask any question. If our questions are there, you can ask in comment section. So as the name suggests, circulation ratio. So circulation. So how does the water circulate in boiler? So that is one video which we have already created, and the link you can find in our video's description, which is on forced circulation and natural circulation. That is on detail, but here also we will cover. So if you see, there is a feed water coming to the drum. If this is a steam drum, then here you might have economizer. So from economizer, the water is coming. So what is the purpose of that economizer? To provide some heat to boiler feed water. And what is that type of heat? We call it is a sensible heat, because we don't want to heat so much that boiler becomes steam. There should not be two-phase flow in economizer. So water is just heated that it will have only sensible heat, and while it reaches to the drum, there will be some, close to saturation temperature. So here there will be steam plus water mixture in drum, and then you have your boiler where boiler is connected to your evaporators and your downcomers. So downcomer, as the name suggests, the water will come to this acid down pipe from steam drum. And then let's say you have your tubes, evaporator tubes. So here there will be heat source, some burners, or maybe some bed CFBC, AFBC, or some gas and oil based burner, or even pulverized fuel firing. So what will happen here? There will be a high temperature significantly. Here there will be low temperature, because these downcomers are not exposed to direct heat. This is a very important point, not exposed to direct heat. That means here the water will be relatively colder, and here water will be relatively hotter. So what will happen? There will be a steam plus water mixture here in this path, in this line. So as the name suggests, the water will evaporate here, and what will happen? The steam will have the tendency to go up. So here there is no direct heat. So water will come down. Here the water plus steam mixture will go up. Why? This is called your thermo siphon effect, and it happens due to delta in density. So you have your steam density, which is little bit lower. You have your water density, which is little bit comparatively higher. So higher density fluid will come down, or lower density fluid will go up. So that is how this process is established, and this is in circulation. This side up, this side down, and this is in circulation. Okay, this is what the circulation is. Now, the next point what we are coming is on ratio. So, just try to understand whatever is coming from this downcomer, and here the something is going up. The entire thing will not go in this saturated steam, which is going to superheaters, because here there will be water plus steam. Here there is only water. So, whatever the steam part, that will go only up. Steam part will go up, saturated steam, and then whatever water was there, water will again come down. So let's say here, if we say X amount is going up, X will be your water plus steam. Then something X dash will go as a steam, then X minus X dash will come as a downcomer in water form. So now what circulation ratio is? So whatever is your steam plus water mixture, it is flowing, and then what your, sorry, it is not superheated, it is saturated steam. So whatever, ultimately this will be same only, because there will be some de-superheater water addition, otherwise it would be same. So your saturated steam. So this is the ratio, flow of the entire mixture which is circulating, and then you have something going out from the drum. So that is your ratio. Okay, I hope you would have understand what is the ratio. Now, how this ratio changes. So let's say I am giving a lot of heat to these area, this area. So what will happen here? There will be a lot of steam generation will happen, and but once the steam generation is up to nucleate boiling range, it is good. It is good that it will happen, and then your water steam conversion efficiency is high, and you are making good quantity of steam. But after this, once there is a departure from nucleate boiling, there is a very high heat flux is there. Then what will happen? Then here there will not be a sufficient circulation, because why? Why? Because here there will be a steam. If you understood the concept of DNB, that if there is a tube, outside there is a heat, and inside there is a steam generation. So in nucleate boiling, what will have? There will be a lot of bubbles generating and bursting, and then new water particle come. But if there is a DNB, departure from nuclear boiling, then there will be a very thin layer of steam will be there, and that will reduce the circulation ratio. The circulation will ratio will reduce, because steam will act as a insulator to the heat transfer, and then you will not be able to circulate much water, and that will cause the damage to tube by overheating. So this is one thing which operation engineer and maintenance engineer has to know. This is one by how it changes in operation. Another part is like this is related to your pressure. So if you recall that steam pressure, steam density is inversely proportional. Yeah, if you recall, the steam density is inversely proportion to sorry, steam pressure. गड़बड़ हो गया यार. So if we remember the older, I mean not older, what we have learned in early school days, that if you increase the pressure, the density of steam will also increase. This is an important concept if you recall. So we will use this. I am just giving a heads up. So this we will use in this understanding of this. So here what we have learned in previous slide also. Here you are giving some heat input and then there is a nucleate boiling happening or boiling happening if you say, then there is a mixture of water and steam, and that this mixture will have definitely lower density than relatively colder water, so it will go up and this will go down and this natural circulation will happen. But what if you have increased the pressure? If you have to make a higher capacity boiler, you are increasing that pressure. So what will happen? As your this pressure is increased, the density difference between this and this, so that will become less. So at that time, your circulation will be low. And if your circulation is low and you are giving that heat again to the system, then what we have discussed in the previous slide, that there will be heat transfer issues because you are circulating less fluid. So to overcome this, there is a boiler circulation pump is introduced in many boilers. So if you see at higher capacity boilers, you will see BCP, boiler circulation pump, which is there to maintain this circulation. So that whatever heat is provided at at this area, sufficient water should circulate so that that water take that entire heat and get out as a generated saturated steam. So this is one important concept where the density difference would come in play. And similarly, if you see that once through boiler, supercritical boiler also, where there is a, if we draw it like that, so there is here, at this point that water and steam density will be equal, so that water is directly converted into steam. There is no intermediate phase. So there, this circulation is not required. That is why it is called once through boilers. There is no circulation. And those ones through boiler, if they are operating below 30% load or they are in startup or shutdown, then this BCP is required. So BCP is there in that superheated boilers also, but that those are required only at lower loads or when you are starting the steam, because that time there will be not sufficient pressure build up, and then you have a mixed phase flow also. So that is how it is impacted. Now, I think what are the important concept I have already explained regarding this circulation number. And one more important thing to note, as you increase the pressure, the circulation ratio number will be low. So that is why at higher pressure you have BCP, and more higher pressure you are having once through boiler. So this is also one relation which you should understand or remember. So that's all on this video. If you have any question, you can type in those questions in comment. We will try to answer. We try to answer on a priority for our members who are our Power Plant Guru member. As then we take that a priority. Rest also we'll try to answer. And we have another a discussion or open session where you can come and ask your doubts and discuss the points is next Sunday, 4 to 5 p.m. Indian Standard Time. Okay, thank you. Thank you very much for being with us.